So, says the foul odor of rancid butter is due largely to butyric acid, a compound containing carbon, hydrogen, and oxygen. That's one of the first clues that it's combustion. The second one is it says combustion analysis. So that's how you kind of know, okay, this is combustion analysis. Of a 4.3 gram sample of butyric acid. What is that? But that's the amount of what? It's the total, right? This is the total of the entire thing. Okay? It produced 8.59 grams CO2 and 3.52 grams H2O. That's the second hint that this is different than a regular empirical. Why?
Because it gives you the molecule.
It gives you the gram amount of a molecule of a compound, not of a single element. Then it says find the empirical formula of butyric acid. So, first thing is like a normal empirical. You take the 2 gram amounts you're given. So you're given 8.59 grams of CO2 and 3.52 grams of H2O. All empirical formulas start the same way, which is what? Change grams to moles by divided by the molar mass. But the difference with combustion analysis is I'm not dividing by the mass of a single element, I'm dividing by the mass of what? Carbon. So I have 1 mole. CO2 is 44.01 grams and H2O is 18.02. Remember, round this to 3 decimals. So I'm going to get 0.195 moles of CO2 and 0.195 moles of H2O. Now, normally in an empirical, this is where you divide by the smallest and figure out the ratios. What's the problem here? You're missing, it's still a compound, you're missing H and you have no O anywhere. Who remembers how you go from compound to single element? Lauren.
You use the ratio from the formula.
Right, you use the ratio from the formula. So if I want to get rid of the CO2 and just be left with C, I say 1 mole of CO2 has 1 mole of C. This now cancels out, and you're simply left with 0.195 moles of carbon. Same thing with the hydrogen. 1 mole, this should be 2 moles H in 1 mole H2O. So I multiply this by 2 and get 0.39 moles H. Now what? We're missing an element, which is oxygen. This is where some of you guys got confused. You have to figure out if this is the total, right here, and I have the amount that's C and the amount that's H, you subtract. But I have to turn these C's and H's to O's. So this is where it gets a little confusing. You got to almost go backwards. So now I'm going to take 0.195 moles of C, and I'm going to make it back into grams of C by multiplying now by the molar mass. But do you see how this is different than the initial calculation, right? This is 2.34 grams C. Because instead of CO2, you're only talking about just the C. And then 0.39 moles of H. And this should be 0.39 grams of H. So now I have a gram amount of C, a gram amount of H, and the total. Where do I get O from?
You subtract those.
Right. So grams of oxygen is going to equal the total right here, 4.30, minus those 2 amounts we just calculated, minus 2.34 You can even put this in parentheses, plus 0.39. So my grams of O is going to equal 1.57 grams. What questions do you have so far? Mikey?
How come you can't just like use the formulas to get the moles out? Like I just want to.
The ones up top?
Yeah.
Because there's two of them. There's O's in both of them.
Is that why? That's why.
Okay, I gotta erase this, but we'll be alright. So where we left off is we have 1.57 grams of oxygen. What do I do with that?
Moles.
Moles by
What?
16.
dividing by the molar mass, which is 16 grams. And I'm going to get 0.098 moles of O. I'm just going to write these down. These are from before. My mole amounts from before. I have 0.195 moles of C and 0.39 moles of H. Now that you have all the mole amounts, it becomes just like an empirical formula. So what do I do?
Divide by.
The smallest, right? So the smallest is 0.098. It's going to give me 1. It's going to give me 2 moles C. And 4 moles H. Do I have to multiply those 3 mole amounts by any number? Why?
Because they're all whole numbers.
They're all whole numbers, so basically I'm done. So what's my formula? C2H4O. Just in general, because some of you flipped the elements around, you should keep the elements in the same order that they're given in the problem. So you're given carbon, then hydrogen, then oxygen. That should be really what you do. Remember, too, that's kind of what organic compounds are. They're carbon, hydrogen, oxygen usually.